We have landscapes that are many, many millions, in fact, hundreds of millions of years old, that we can just walk over today, and see. And it's building our connections and understanding to that landscape that enable us to read those old areas and understand those old bits and what's gone on and how we can better live with them.
Hi, and welcome to Wonder, the Planet Earth podcast for curious people. I'm Holly Cook, joined as always by fellow Earth scientist Dr. Anthony Reid. And Anthony, today we have just the delightful privilege of sitting opposite Dr. Steve Hill, Chief Scientist at Geoscience Australia. Steve, have you been well?
Yes, I have. Thank you, Holly. Hi, Anthony.
G'day, Steve.
Thanks so much for coming in. Anthony and I, for a long time, we've always sort of blasted up into outer space in our imaginations and casted an eye downwards at the Australian continent. And I can't think of a more perfect person to begin to talk about what actually constitutes the Australian continent. What are our landscapes? What makes Australia so unique if we're to go out on this cosmic picture of what our beautiful country is? Steve, where do you even begin to think about Australia like this?
Right. So let's go on that journey. Hey. So if you think about Australia, if you were to have to try to find it within a jumble of a planet Earth and you didn't know where you were and what you're looking at, two big things that would give it away are that it's extremely flat or low relief, big high mountain ranges, and it's very red.
The red country, yeah.
And that flatness and that redness is all due to its geological and environmental evolution over many millions of years. And that's what's really exciting. We think it's the here and now. We think it's just the way it is. But a lot has gone on over a long time to make it like that.
Right. So like the criteria in our head, if we're looking at just a jumbled planet Earth from outer space, is this flat and is it red? And it's not a coincidence that it's flat and red.
That's right.
Right.
So one of the big things about the reason that it's flat is, yes, its position away from tectonic plate boundaries. So we don't have those, upheavals and jostlings around going on as much in the continent. We still have a bit, but not as much. But the other big thing is the antiquity or age, the old age of Australia's landscapes. And it's remarkable, right? We have landscapes that are many, many millions, in fact, hundreds of millions of years old, that we can just walk over today, and see. And it's building our connections and understanding to that landscape that enable us to read those old areas and understand those old bits and what's gone on and how we can better live with them.
So when you say that the landscape is old itself, so often people will stop us and they find out you're a geologist and they say, tell me about the rocks. Which happened to me this weekend, and someone asked me, can you tell me about the rocks? And I was
yes, like, I can.
Yes, I can. But what they wanted to know about was why was it this colour?
Yeah.
Which I hadn't really even thought. I'd sort of looked past the colour and I'd say, so Steve, how do you know the age of a landscape that you're looking at?
That's actually a great question that goes all the way back to when scientists, so traditional scientists, started looking at Australia geologically. And many of those scientists came from the Northern Hemisphere, where the landscapes are typically quite young because of, glaciation and plate tectonic processes. So they came to Australia thinking it would be much the same. But once they started mapping and getting better ages on the rocks and the sediments, they started to realise that, no, it's very, very old. So, a landscape is, we're talking about the plains and the hills and the rivers and all that, and the dunes and
what
beaches.
You see.
What you see at the surface or near the surface.
Yeah.
And that has to be young. It has to be younger than that age of the rocks. Right. So once we know the age of the rocks, we can start saying, well, it's younger than that. But then some landscapes get buried and exposed, or some landscapes are closely related to another lot of rocks. And therefore we can start to fill the gaps in that geological puzzle to say, hey, these landscapes go all the way back to the Permian period or something like that.
I was going to keep it to myself because it's a bit of a bendy question, but given it's kind of been opened up, I have tied myself in knots thinking about this conversation with you, Steve, because the concept of a landscape versus the things in the landscape, like the rocks in a landscape, the rocks that constitute the landscape versus just the sum of what the landscape is. Like, what is sorry to be so esoteric, but what is a landscape to you?
Yeah. So one of the complexities here, and this is one of my favourite things about this area of science, is that landscapes also continue to evolve.
Mm-hmm.
They're dynamic. So we talk about, say, fossil landscapes or ancient landscapes that are sitting in here and now in our current landscape. But the reality is that they're still contributing to landscape processes that are happening today. So people often ask, what is the age of that? And it's like, well, it's actually continual. So when we talk about old landscapes, in actual fact, what we're talking about is that general form of, say, a hill, a river, or a plain, that the origins of that go back to that time.
Mm.
And it is remarkable, though, that by and large, there are a lot of places that you can go to and put your hands on and touch, and that is undoubtedly the same as it was millions of years ago. The great example being, say, the Permian. We had these big Australia was at the South Pole. It was all joined up to a lot of the other Gondwana, parts of Gondwana. And we had these glaciers, right? We see them at Hallett Cove. You see them in central Victoria, Bacchus Marsh, Heathcote.
Beautiful.
Lots of places in Australia. And the reality is you can still touch the rocks there and you can still see where glaciers have scratched those rocks. And I've got a photo up here that shows on the shores of Lake Epilock, one of those surfaces with these big grooves where a glacier in the Permian. So what's the Permian?
It's like 250 million years ago, something on that order.
Moved across the surface, and you can see that as pretty fresh today.
That's an astonishingly large amount of time to preserve a feature from the surface.
This is what gets me about what you just said about the preservation of landscape is I just think of the word form. Like it's actually when you say you can walk through a landscape, it's not like, you have to imagine when you're walking through a landscape, its form has been preserved for such an astonishing long period of time. So if you do have access to video, if you're driving or whatever, that's okay. Come back to this later. But if you do have access to video, Steve, something that Anthony and I wanted to do with you, and you've great that you've opened this up, is ask you about maybe driving pit stops. As an inhabitant of this big country, we spend a lot of our time in our cars driving across it. Hey, and I think everyone's familiar with sort of
long, boring road trip.
You've spent a couple of hours on the road and then you open up the door and go, where am I? And well, it's just some weird dimension.
Are we there yet?
Correct. So tell us more about that photo that you just flicked up there. Where are we? Yeah, correct.
So that one there is in Victoria, from the shores of Lake Epilock, which is just near Bendigo, so central Victoria, almost the dead centre of Victoria. And these are Ordovician sedimentary rocks that have then in the Permian had a glacier moved northwards across it. And this was at a time when Australia was pretty close to the South Pole.
Wow.
And we had big ice cap, very thick ice cap, and that ice would have been carrying bits of rock and things like that. And as that has moved northwards, that has scratched this rock. And so you can see the direction of movement of the rock. But the really amazing thing is you can actually touch that bit of landscape that was near the surface when that glacier was moving across that area. And that blows me away.
Totally.
And that, for this area, was really one of the sort of origin events that then set the scene for all these other landscape things that have happened over many millions of years, since 250 or so.
What do you mean set the scene? We're talking about a glacier on a rock. What do you mean?
So when rocks are near the surface, they weather, they alter. They, particularly if they've formed in a different environment or if they're from deeper in the crust, they're out of equilibrium when they're at the surface. So they adjust through a process called weathering, and you get things like oxidation, reactions with water, just a couple of really good examples of that. But then what happens is they'll also erode, right? And so those variably weathered, some fresh, some weathered, real mixture, they will erode and they will form the next lot of sediments. And then they have a whole landscape story because the sediments were actually deposited, say, in rivers or in the sea or in lakes or along the coast. And so we're reproducing this understanding of these old landscapes by understanding those surface geological materials. And these are materials that are often ignored by people because they sort of think, oh, no, we want to know about the hard rocks. It's almost like as a geoscientist, the harder the rock you look at,
the more geo you are.
The more geo you are. Oh, yeah. I've had to live
I feel seen. Okay, I admit it.
Don't look at the geochronologist over there.
So I've had to live with working on very soft, very weathered, very near surface rocks. So
we all went across the bears.
Yeah.
Exactly right.
Yeah.
So, but I actually find them, for me, they completely blow me away because what I've always wanted to do in my life is understand our country, our landscapes, the places we go to, what you see at the surface and what we can read in that, what we can understand about its history, what's at depth, how we live with it, all of those sort of things. I love that.
I know you love it. One of the things I remember you telling me quite a while ago now was your fascination with some of the early European explorers.
Mm-hmm.
And some of them who lived or died, in a sense, by their ability to actually read the landscape.
Yeah, and also misunderstood. I think is the other thing about it. I'll give you one example. I mean, look, a great example was when Europeans settled at Sydney. One of the things that they wanted to try to do was, move out of Sydney, but they were hampered, right? Because if they wanted to go west, they got the Blue Mountains, so they had to kind of understand that landscape. They also had to talk with people that had been living there for many thousands of years. Who had knowledge and experience.
Exactly.
But they had to understand that landscape to move west. And the other one I really love is Charles Sturt.
Mm-hmm.
We're in Adelaide, and Sturt lived in Adelaide. And he was obsessed with finding an inland sea.
Mm-hmm.
And we think about Australia and we think, oh, that's crazy. But at that time, large inland lakes and seas were being found around the world, and they were opening up areas for trade and prosperity and things like that. But the clever thing about it, what Sturt did, and I know he did a lot of things that people go, oh, he's flawed in some ways.
He's a man of his times.
But the amazing thing that he did was he read the landscape with that idea of the inland sea. He and others knew or figured out that a river flowing west from inland to Sydney would not be able to sustain its gradient to flow out at the west coast, because that's what it was originally thought. Oh, those big river mouths in Western Australia. Oh, that's the start of the Murray, or that starts as the Murray and goes all the way.
Let's just picture that. So, if you're not familiar with Australia, check it out on a map. But that's probably how many thousands of k's from east to west?
Yeah, right. So
it's probably 7,000 or 8,000 kilometres. It's like a long way for a river to flow. And so that's a great observation, simple observation. The gradient of that river couldn't sustain the delivery of water across an entire continent. So it must have emptied somewhere in the centre.
So maybe that's an inland sea like we're finding in other continents, right? So
I'm still just thinking about inland seas as if they're like coming in vogue. I just imagine Charles Sturt maybe going, oh, it's becoming trend. All these inland seas being discovered. Where's the
he'd be reading
it's the new thing on the block.
The Victorian Inquirer.
Correct.
Inland sea FOMO. Yeah.
Where's ours?
Yeah, but and the other great thing, or the amazing thing about it, is that indeed Australia did have an inland sea.
This is so incredible.
But it was in the Mesozoic, 200 or so million years ago, when there were dinosaurs and amphibious reptiles and that swimming around, and the world was very, very different. But we did have an inland sea, and here's the twist. Parts of our landscape that are still exposed originated at that time. So some of what you see in that land today actually is a vestige of the time when there was inland sea. So it's not as crazy as you think.
It's not as crazy. But it is crazy as well.
Well, the poor guy, he towed a huge team and a whale boat, and he ended up he ended up getting scurvy and all these sort of things that people get.
Yeah. Your point about this makes me think of many things being true at once, because I'm still looking at that photo, and I mean that's okay, because I think this will be a feature of every photo that we look at, which is a harmony of time. So when you're looking out in a land, when you're just existing in a landscape surrounded by the shapes of its trees or the shapes of its gullies or the hills in the distance, you're looking at like a real mosaic of time. And so to your point about looking for an inland sea while actually trekking over landscapes that were formed by an inland sea 200 million years ago, there is just a mosaic of time that exists in Australian landscapes. Do you have another photo for us? Do you have another pit stop?
Sure. Where do we want to go? Do you want to go...
something related to the inland sea.
Oh, let's do that. We'll go to Western New South Wales.
All right. What are we looking at?
So this is near the town of Tibooburra, which is in the far northwest corner of New South Wales, very close to the Queensland and South Australian borders.
Beautiful.
And what we can see here is it's currently an arid landscape.
There's a couple of bits of grass and a few little bushes there, but otherwise it's dirt.
Quite sad
There's a lot-
grass.
There's a lot of red fine sand.
Red fine sand.
Yeah, I've got to be careful about using dirt. You know what dirt,
Did I say it already? Did I?
You said dirt. Yeah, the dirty word. Now, I'll tell you a bit about dirt, Anthony Reid.
Yeah, please tell me about the dirt.
Dirt is basically soil that's out of place.
Thank you.
So just as a weed is a plant that's out of place, dirt is soil that's out of place.
Gotcha.
So
Okay.
this is very much in place.
It is
This is
soil.
where it's meant to be. So it's a soil or a sediment. Yeah. I have copped the dirt.
So many
dirt
years.
doctor. And all this sort of
Stop,
stuff.
Dr. Dirt.
Yeah,
Oh, you
all
poor
that.
thing.
Well, Steve, I can hear the violin, Steve.
Yeah, that's right. Yeah. Anyway, moving on from my therapeutic outpourings. This landscape, and for those who can't see the photo, I'll describe it. It's got on the left, it's got these what we call tors, these large blocks of Silurian granodiorite. So
Silurian.
And
Silurian. So that's like 450,
Probably
420.
Another name that
Yep.
another name that we give a chapter in Earth history, the Silurian.
That's exactly
Yeah.
a period of time. So yeah, very old, and that's a granodiorite, which is like a granite. So it formed. It was a molten rock, and it solidified deep in the crust. It's then been exposed, and the hill in the background is composed of sediments that are a combination of river sediments, and eventually they become marine sediments. And those marine sediments are from that time of the inland sea about 200 million years ago. So you find amazing fossils, fossils of plesiosaurs and things like that in those sediments. But at the bottom where there's a lot of rivers, you find bits of fern and fairly primitive
amazing.
plants. But the big kicker here is those sediments are also have a lot of gold in them.
Weird.
So Tibbaburra was famous for its goldfields, and in fact, very famous now for a lot of prospectors go up there. And they say you can walk the streets of Tibbaburra and pick up gold nuggets. The reason is
Kangaroos and gold nuggets. Welcome to Australia.
all that sort of stuff. Yeah. And
I don't see a Bunnings in that photo, actually.
That's postmodern Australia.
Well, it's such a classic Australian thing because you can see there's some excavation in the hill at the background,
I
and that's
see.
where they got the stone to make the family hotel
There
at
you go.
Tibbaburra. So,
There it is.
but the amazing thing is it's like, oh great, those sediments hold gold.
Yeah.
But where did the gold come from? To understand that, you need to understand the landscape of the Mesozoic and trace those rivers back to their sources and things like that. And I just find that is so exciting. We've got this amazing environmental history of, rivers with ferns and inland seas with plesiosaurs, but we've also got this gold moving around and there's like a puzzle to solve. That's great. You can find little gold nuggets, but there must be some area where there's more of that gold that's all come from.
Oh my gosh. So that hill in the background, that dusty orange hill in the background, if you were to read the landscape presented by this photo, you would have to, what is implicated is an ancient river, ancient animals swimming around in something that came into an ocean. But then you have to consider what was the floor of that ocean, the base of that ocean, because it had incoming sediments that were being eroded from something. And all of this is happening how many years ago?
Well, it started, 250, 200 million years ago.
God.
But the thing is, it's continuing today because that's all getting eroded and it's, washing more sort of pebbles and gold around today. So you can find gold in the modern streams that's washing out of these. And then you've also got that red,
Soil.
well done.
Thank you. Learning.
Every day's a school day. You've got that red soil or sediment. And the thing is, that's even younger again. And that represents the another part of the story, and that is that increased aridity of Australia as it's been drifting northwards as a continent. It's moved into dry zones of the earth. And then we've had a lot of wind, less vegetation cover and a lot of wind-blown dust moving around. And that's what you see there. So it's a very dynamic landscape.
Unbelievable. I just want to dwell a little on something that you dropped in there, which was Australia drifting. I feel like that deserves a couple seconds. What do you mean? Increased aridity. So the younger red stuff on top, I'll just go with stuff instead of dirt. The younger red stuff on top, a drifting Australia, what do you mean that's recorded in the landscape?
Yeah, so I mentioned earlier how when we talked about ancient landscapes, and Australia was part of a supercontinent called Gondwana. And what's happened over time, and this happens to, continents and big land
It's just
masses,
something that happens.
is they break up and then they move around the surface of the planet, continental drift, if you like. They're moving around. Well, what's happened with Australia is that it was part of Gondwana. And then Gondwana started to break up, and then that led to isolation of Antarctica, Australia, India, Africa, South America, all those places. And what they've done since breaking up is that they've drifted, they've moved about to their present position, and they're still moving today. In fact, Australia is moving 7 centimetres a year, which is the length of your little pinky finger, or the other way to think about it, it's the same pace
of my sister getting out of bed in the morning. Sorry to interrupt.
No, you're fine. The same pace as our fingernails grow.
That's crazy.
Australia is moving at that pace. Just think about that, though. I mean, this gets back to some of my work at Geoscience Australia, where we're trying to map a continent and we're trying to have a gridded, sort of reference system and coordinates.
But it's moving.
But it's moving. Right? That's a whole nother story in itself. But so what's happened is Australia has moved in that time pretty much from the South Pole to then become one of the, I think it was the fastest moving continent for a while there. And eventually the plate that Australia's on is colliding into Southeast Asia, Papua New Guinea and places like that. But on its way to do that, it's moved from a sort of high latitude polar zone in through the sort of mid latitudes, which are more arid. And the other thing that's happened is the Southern Ocean has developed this really strong circumpolar current that's driving weather systems and so forth. Anyway, the upshot of that is that we have increased aridity. Australia moves into an arid zone. So our, ferns and everything and beautiful sort of almost kind of rainforest, it's not quite, but it's kind of, that has been under stress. And what we're starting to see in Australia is more fire and this drier, what's called sclerophyllous, which means hard-leaved. Eucalypts are a great example. Hard-leaved plants that burn, but that's had an impact on the landscape. Mm-hmm. So we see that aridity shown by more wind-blown sand, so the red sand dunes and the white sand dunes. But also we see these little pebbles of magnetic rock, right? Little iron-rich pebbles that you see around. You get a little magnet in the soil and these little things stick to it. That's called maghemite. And that actually forms when the soil has experienced a fire and these little pebbles take on magnetic properties, which is amazing. So you've got these little pebbles that you see everywhere. They're really common in, across Australia. They've formed, in the last, 20 or so million years from that increased aridity and prevalence of fire. And, the changes in vegetation. We also see our soils become very rich in calcium carbonate and calcium carbonate and other salts. And that's because there's less rain, so they're not leaching away. So we see the so-called calcretes in South Australia in particular, in Western Australia.
Oh my gosh, is your brain just going back to? No, this is so fantastic because we had a couple of excellent conversations with Andrew Meredith, University of Adelaide, who basically got up on a screen like the dance of the continents, and looked at plate tectonic reconstructions, and we kind of had a joke. Just trust me, bro. This is what happened. This is what it looked like. But what is being said here is that you can actually walk. In 2025, you walk through a landscape and you're like, no, maybe they're onto something. This is these are formations and soils and sediments that come about in drier, arid, more arid landscapes. Do you know what I mean? Like that's the evidence. You're walking through it.
This is what you're unlocking here, Holly. This is amazing, right? So we often think that movement of continents is something that resides in deep time, deep hard rocks, and something that's in the interpretation and the imagination of boffins, geologists and whatever, right?
Yeah.
But the reality is that we are living on some of those surfaces. We are walking around them and we have to live with them. We get resources from them, mineral resources, energy resources,
we build cities on top of them.
All of those crop them. They explain our soils. They explain so much about our life. And it's not just a sort of
some airy-fairy big data question. It's actually, even though it's tremendous to have those insights. Yesterday's landscapes are today's lived experience, and that's a beautiful thing about. I won't say dirt. I won't ruin the beauty of that. That's a beautiful thing about a conversation with you, Steve. All right, so where to next?
Okay, well, I've got a photograph here of a mountain and a road with sugarcane growing on either side of the road.
So green.
Iconic.
It's amazing. I was here just last week. Right, so this is where
Hot off the press.
That's exactly right. It's very, very fresh in my mind.
Yeah.
And the mountain there is made of granite. It's a mountain called Walsh's Pyramid. And for those that can see the photo, it's got this amazing sort of triangular, pointy, it's actually conical. It's an amazing mountain. It was actually the First Nations people in the area draw parallels between that mountain and the mounds of scrub hens. Right?
Oh, beautiful.
Very important signpost in the landscape that they all use too. But the thing that's incredible here is that I have been working in the last week with First Nations groups from this area, and what they're looking at is combining their Indigenous knowledge of landscapes and how they work with traditional science. And so we're talking about reading landscapes from a scientific perspective to then bring that into the realm of, Indigenous or First Nations knowledge is just amazing, right? And so this area, was cleared to have the sugarcane farms put in, and that cleared out, old swamps and old plains and things like that. As a result, the erosion in that area means that rivers like the Russell River, which is the main river through here, is the largest deliverer of sediment to the Great Barrier Reef, plus the nitrogen that they add to grow the crops dissolves, goes out through the rivers, goes out into the reef. And that Russell River is also the largest deliverer of dissolved nitrogen to the reef. And nitrogen is pretty dangerous if you're coral because it actually supports algal growth, makes the water go greenish, but also coats everything with algal sort of scum. Scum's probably not the right word to use. But
if we're talking to a biologist, it might be as inflammatory as your comment about
scum. But the thing I've loved about this landscape is really, to work as a scientist with First Nations groups and bring that together for a better outcome. And what we're all looking at here are parts of that landscape that may be able to sustain cropping, but areas that shouldn't or can't, and what we can do to help, recuperate those, but also to ask the question about how resilient is this landscape to future climate change? All right, so if we have warming, we have sea level rise, what will happen? Well, this area has a landscape history of being submerged when the sea level's a bit higher. So that will raise the water table, that will cause flooding, that will make some of these areas even less productive. So what can we do? And some of the ideas are around, creating or recreating wetlands, planting species that are kind of keeping ahead of the curve of what's happening in the catchment, but also just understanding the dynamics and the processes in the landscape. And I'm really proud to be working at Geoscience Australia, where we're looking to really integrate our work with groups like this in these areas and pull together those data sets.
Fantastic.
To help connect and understand the landscape in so many different ways.
Amazing.
Brilliant.
That's really remarkable. Thank you for sharing that, Steve. I just think about, it's one thing to go and, look at the trees and look at the cliffs and go, oh, wow, I live in an ancient world. But it's another to consciously recognise that how we go about living our lives today in this country, utterly depends on what these environments used to be. And I think First Nations knowledge it's so obvious to say, isn't it, that integrating those knowledge systems together is how we should be going about understanding how these environments will respond to different circumstances in the future.
Yeah.
So thanks for a tremendous conversation. This is fantastic. Road trip with Steve, hey.
Excellent. Thanks, Steve.
Thanks, Steve.
Good on you.